All right, we're going to be talking about isosceles and equilateral triangles today. But before we get into those specifically, we're going to talk about ways that we can classify triangles. There's two ways that we can classify triangles. We can classify them by their side lengths, or we can classify them by their angle measure. So we're going to start off classifying them by their side length. So the first way is called a scalene triangle, and a scalene triangle is a triangle with no sides congruent. So if I draw a triangle here, I'm going to have three different measures. None of the sides are going to be the same there. So if you see a triangle with three different side lengths, that means that we could call that triangle scalene. Isosceles triangle is a triangle with at least two sides congruent. So I could have 5, 5, and 6. Now, in this same thing here, I want to talk about, we talked yesterday how there's going to be a lot of symbols and shortcuts in geometry, and there's going to be markings on diagrams to help us. So they won't always show you an isosceles triangle like this where they'll say two sides measure 5. They'll use markings on the diagram. So another way to show this is, I'm going to draw another triangle over here on the right, is they use what they call hash marks or tick marks on the sides. And they both have one hash mark or tick mark. That is telling us that those two sides have the same measure. So it's called a hash mark or tick marks. Are used on diagrams to show congruency. And for two things to be congruent, that means we're saying that they have the same measure. That's what it means to be congruent. They have the same measure. And then the last way to classify a triangle by its side lengths is what we call an equilateral triangle. So we've had no sides congruent, two sides congruent, which leaves us with all three sides congruent. Just like the name implies, equa meaning equal, lateral meaning side. So it says equal sides in the name. So in this case, I would have a triangle. Let's say these all measure 3. But again, another way that I could show that, going back to those hash marks or tick marks that we just had, I could draw that same triangle, and instead of using the numbers, I could put those marks. Now you notice I used 2 marks per side this time. There are some diagrams when there's more than one set of congruent parts. One hash mark would match up with one hash mark, 2 with 2, 3 with 3, and so on. You match up the number of marks on the side. So in this case, I put 2 on each side. Same thing, that is saying that all 3 sides have the same measure. And you can classify by side length and angle measure at the same time. It's not like it's exclusive where it has to be one or the other. A lot of times we would call it an acute scaling triangle or a right scaling triangle, just depending on what information we have. So the next, you can see there are 4 ways. Now there are some errors down here that I did not catch. First off, anywhere in this bottom part where it says congruent, we need to cross that word off. That word did not belong down in this bottom segment. Obviously, I copied and pasted and did not pay attention to when I copied and pasted. And there's one other error down here. You see I repeated the word equilateral. On the bottom down here in the angles, this should be equiangular. So again, there are 4 ways to classify them by their angle measures. An acute triangle is a triangle with all angles less than 90 degrees. So I could have 55 degrees, 65 degrees, and 60 degrees. If you add those 3 numbers up, it fits to what we talked about yesterday, that all 3 angles in a triangle have to add up to 180. So it still fits that narrative, but each of the angles is less than 90 degrees. So we would call that an acute triangle because none of the angles are 90 or greater. All of them are less than 90. So if we see that, we're classifying it as an acute triangle. An obtuse triangle is a triangle with one angle greater than 90 degrees. And you can only have one obtuse angle in a triangle. It's not possible to have more than one because, again, of that whole having to add up to 180. If one of the angles is greater than 90, we're already halfway, more than halfway to our goal of 180, so there's no way to have 2 obtuse angles. So in this case, we can have an angle with 110 degrees. Let's say this one is 30 degrees and this one is 40 degrees. And then a right triangle, we actually talked about a right triangle yesterday, but a right triangle is a triangle with one angle that measures 90 degrees. And again, if that angle is 90 degrees, we know the other two angles have to be less than 90 because again, they have to add up to the 180. Now we did talk about the symbol for right angle yesterday, so I'm going to draw a second one here. Again, showing that box in the corner and just reminding us that that is the symbol for right angle. So anytime we see a box like that in the corner of a diagram, doesn't even have to be a triangle, it can be any other shape, but anytime there's a box like that, they are telling us that we have a right angle or that we have an angle that measures 90 degrees. And then the last way to classify a triangle by its angle measure is equiangular. And an equiangular triangle is a triangle with all three angles having the same measure. So we're going to find out that an equiangular triangle does go hand in hand with an equilateral triangle. The equilateral had all three sides congruent. The equiangular has all three angles congruent. So if we think about that, going back to yesterday's lesson, and all the angles have to add up to 180, if all three of those angles are the same, what is 180 divided by 3? 60. So every time you have an equiangular triangle, there is only one measure for those angles. They are always going to be 60 degrees. Because if I take that 180 and I have to divide it by 3, it's going to come out to the same number every time. It's not like it changes every time I divide by 3. So if you have an equiangular triangle, that's going to happen. Now, just like there were markings for the side measures, there are markings for the angle measures as well. Instead of having to write the 60s in there, we can use what we call arc marks. So you can see I can put these arcs in each of the angles. These are arc marks showing that the angles are congruent. Now, I'm gonna add a little asterisk here at the bottom, and we're gonna add a little bit of information because an equiangular triangle and an equilateral triangle are always going to be one and the same. So a triangle that is equiangular is always equilateral. And it works the other way. An equilateral triangle is always equiangular. Those two always go hand in hand. You cannot have one without having the other. So if they give you the markings to say it's equilateral, you know that it's also equiangular. And vice versa. If they give you the markings to show it's equiangular, then you also know that it is equilateral. One cannot happen without the other. Now, I also left something else out, but luckily we have that page 10 right next to this that is blank. So on that page 10, that blank page, we're going to add a little bit more about the isosceles triangle, because obviously that is one of the main focuses of this lesson, is talking about that isosceles triangle. So again, you're just going back to page 10, which is the page right next to it that is blank. We're using that page. And there's a few more parts. We already said an isosceles triangle has at least two sides congruent. So we have our isosceles triangle. I put my marks on there. But there's some other parts of the triangle that we need to talk about. Okay? Because there are specific parts here. So again, we just talked about an isosceles triangle has at least two sides congruent. This angle at the top that is between those two sides, that is called the vertex angle. And the vertex angle is the angle that connects the two congruent sides. And I'm going to use this symbol for congruent there. And the reason is I want to be able to talk about it. The congruent symbol is the equal sign with the tilde over it. That is the symbol for congruent. And if two things are congruent, we are saying that they have the same measure. So that vertex angle is the one that connects those two sides that are equal to each other. And then the two angles at the bottoms of those two sides, these are called base angles. And the base angles are the two angles opposite the congruent sides. Now, there are two theorems, that apply to the isosceles triangle. The first theorem is called the isosceles triangle theorem. And we're going to talk a little bit later about what is a theorem, what is that telling us. But the isosceles triangle theorem says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. And then there's a converse of this theorem. And a converse of a theorem just means I can take the first theorem and switch the two parts around. In the first one, we said if the two sides are congruent, then the angles are congruent. The converse is this is true, where we could start with the angles and then know about the sides. So again, it's called the converse of Isosceles triangle theorem. That says if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So again, you're seeing that there is a relationship between angle measure and side length. It's not necessarily that I can tell, except for the equilateral. That is the only one I can know specifically. I don't know that I can say what the side length or the angle measure is, but if those two sides are congruent, then I know the angles opposite those sides have to be congruent. Those base angles have to be congruent in an isosceles triangle. All right, now let's go to page 13 and let's look at the math that we're going to use behind these ideas. So now that we know some information about isosceles and equilateral triangles, let's use that information for the math. So on all these problems, they want me to find the value of x. So I look at this first diagram. I'm just going to darken in the marks that are already there just to highlight them. They're showing me that two of the sides are congruent. So we just said in the isosceles triangle theorem, if two sides are congruent, then the angles opposite those sides are congruent, which means that this angle here would have to be congruent to this angle here. Now, in this particular example, there's no math to do, because if one of the angles is 49 degrees, what does the other angle have to be? 49 degrees. They're the same measure, so we can just say x equals 49 degrees. Now, are all of them going to be that easy? No. But we do, just to understand the idea, that if two of the sides are congruent, I know that the angles opposite those two sides are congruent. So if one of those congruent angles is 49 degrees, the other congruent angle has to be 49 degrees. In the second example, they're showing me that all three sides are congruent. Well, again, we talked about that's an equilateral triangle. If it's equilateral, it's also equiangular, which means that all of these angles are also congruent. And we said, well, if all the angles are congruent and we take that 180 and divide by 3, you told me that was 60 degrees. So I know that each of these angles is also 60 degrees. So again, in this particular case, there's really nothing to solve. We would just say x equals 60 degrees. It's just about understanding, do I have an isosceles triangle or do I have an equilateral triangle? But again, all the problems are not going to be that easy. They are going to get a little more complex, as we're going to see starting with example 3. Instead of just giving us a variable in example 3, they're going to give us an expression. So we're going to have to use that information plus what we know about isosceles and equilateral triangles. So in number 3, based on these markings, do I have an isosceles or an equilateral triangle? Equilateral. All three sides are marked, so I know if all three sides are congruent. I also know that all three angles are congruent. And in the case of all three angles being congruent, I know that that means that all three angles have to equal 60 degrees. Now they told me the measure of angle 2 is x plus 67. So that x plus 67 is representing that angle there, that angle 2. So how we would set this up, we would say, well, the measure of angle 2 equals 60 degrees, but I'm going to substitute x plus 67 in for angle 2. So I would say x plus 67 equals 60. And then I need to subtract that 67 from both sides. And I get x equals -7. It is okay to get a negative value for your variable as long as when you substitute it back in, it gives you a positive measure, because angles and sides are both measurements. So if I substitute that back in, -7 plus 67 equals +60. So it's okay to have a negative variable as long as you have a positive measure once it is substituted in. Number 4, looking at the markings that they have here, is this an isosceles triangle or an equilateral triangle? Isosceles. 2 of the sides are marked. And since it's isosceles, we know that the angles opposite those sides have to be congruent. So I know this base angle has to be equal to this base angle. Well, if one of the base angles is angle 2, the other base angle is also angle 2. So the measure of angle 2 plus the measure of angle 2 plus that 72 has to add up to that 180. Now, for the measure of angle 2, they told us, well, the measure of angle 2 is x plus 62. So that's going to represent that angle down there and that angle down there. So really, when we substitute that in, I have the quantity x plus 62 plus the quantity x plus 62 plus 72 equals 180. So it is possible they will give an angle a name of a number. But as long as they give us what that number is worth, we can still solve it. Now I'm just down to problems like yesterday. I'm just solving equal to 180, so I'm combining like terms. X plus x gives me 2x. 62 plus 62 plus 72 gives me 196 equals 180. So I have 2x plus 196 equals 180. I subtract the 196 from both sides. I get 2x equals -16. Divide both sides by 2. And we get x equals -8. And again, it's okay to have a negative value for the variable as long as when I substitute it in, it gives me a positive. -8 plus 62 would be 54. 54 is a positive value. And if I were to take 54 plus 54 plus 72, they would add up to 180. So I'm still holding true on my triangle sum theorem while solving for an isosceles triangle. 196 is when we're combining like terms, if you take the 62 plus the 62 plus the 72. So combining those three terms together gives you 196. All right, number 5. Do I have an isosceles triangle or an equilateral triangle? Equilateral. I have all three sides marked, which means that all three angles are also congruent, which means all three angles are also 60 degrees. So they're telling me the measure of angle 2 equals 9x minus 3. So that 9x minus 3 is what we're going to use to represent angle 2, because we know that the measure of angle 2 equals 60, but I can substitute in 9x minus 3 equals 60. So I can add 3 to both sides. So 9x equals 63. Divide both sides by 9. And I get x equals 7. Number 6, do I have an isosceles or an equilateral triangle? And again, the difference comes down, do I have 2 sides marked or do I have 3 sides marked? How many sides are marked in number 6? 2, which means I have an isosceles triangle. And if I have an isosceles triangle, that means the angles opposite those sides are also congruent. So if the angle on the bottom right here is angle 2, that would mean that is also angle 2 if they're congruent. So again, here I have the measure of angle 2 plus the measure of angle 2 plus 70. I'll have to add up to that 180. But they told us the measure of angle 2 was 12x plus 7. So that 12x plus 7 is what we're going to substitute in for both of those angle 2's. So really I have the quantity 12x plus 7 plus the quantity 12x plus 7 plus 70 equals 180. Combining like terms, I have the 12x that I'm going to combine with the 12x for a total of 24x. And then I have 7 plus 7 plus 70, which is going to give me plus 84 equals 180. Subtract 84 from both sides. We get 24x equals 96. Divide both sides by 24. And we get x equals 4. So the first part is going to be being able to determine, am I dealing with an isosceles triangle or am I dealing with an equilateral triangle? That is going to be the first order of business that we're going to have to tackle before we can solve. But once you know how to set up the triangle and solve for that missing part.